Easy to see, hard to find. Planet Nine's, or what we call Planet X Nibiru, orbit mapped to the solar system. Scientists Michael Brown and Konstantin Batygin of Caltech presented a map showing the likely orbit of a ninth planet in the solar system. The Japanese 8-meter telescope Subaru is to search for it. The two scientists presented a map showing the probable orbit of Planet 9, and they designated it as P9 and its possible current location within that orbit, inviting everyone to look for the new planet. Michael Brown and Konstantin Batygin, who work at the California Institute of Technology, announced it in early 2016 that they had evidence of the existence of a ninth planet hiding somewhere in the outer solar system. And now they've made it a map. They made a map showing exactly where it might be. An article about this published in an astronomical journal, preprint, available on arxiv.org. And according to the astronomers, the red area on the map is the most likely located for a hypothetical yet undiscovered planet in the solar system. The wavy black line, which repeats the bends of the colorful curve, is the designation of the ecliptic, in the plane of which the Sun and the orbits of all our known planets are located. The ninth planet, or Planet X Nibiru, will be somewhere on a colorful wavy line. In this case, the red area is indicating the farthest from the Sun section of the orbit of the ninth planet, and it's there that it moves most slowly and therefore spends most of its time. Unfortunately, our data can only show the approximate path of this planet in orbit, and it's not its current location, says Michael Brown, but it's most likely to be at the farthest distance from the Sun, simply because it moves the slowest there and spends more time there, and you should look for it there, he says. 5 planets observable with the naked eye, Mercury, Venus, Mars, Jupiter, Saturn, have been known to mankind since ancient times. The planet Uranus was discovered by William Herschel in 1781. Neptune was found in 1846 by Johann Hall and other astronomers according to the calculation of Le Verrier and Adams. Pluto was just found in 1930 by Clyde Tombaugh, but in 2006, by the decision of the International Astronomical Union, this subplanet was deprived of planetary status and downgraded in the rank to a dwarf planet. An important role in this was played by the discovery of Eris and other larger Plutoids from the Kuiper Belt. Kuiper Belt objects are icy bodies left over from a formation of the solar system whose orbits are located farther than Neptune. Pluto is the same Kuiper Belt object as Eris, Makemake, and Haumea. The man who did away with Pluto is considered Michael Brown, since it was after his discoveries and on his initiative that Pluto was demoted. In 2010, Brown even wrote a book, How I Killed Pluto, and now he's looking for the real ninth planet, which is significantly larger than Pluto in size and mass. For the first time, the idea of existence of a large planet on the outskirts of the solar system and the possibility of finding it by analyzing the orbits of Plutoids was visited by Brown in 2003 when he led a group that found Sedna, an object only slightly inferior in size to Eris and Pluto. Sedna's unusual orbit made it the furthest known body in the solar system. At that time, even the point of its orbit closest to the Sun was located 76 astronomical units from it. 1 astronomical unit is the distance from the Earth to the Sun, about 93 million miles, beyond the Kuiper Belt and far beyond the influence of Neptune's gravity. A simple explanation suggests itself. There is something very massive in that region that affects the orbit of Sedna. However, with a small probability, Sedna could be influenced by the gravity of some nearby star at the early stages of formation of the solar system. Combining Sedna and 5 other well-known distant trans-Neptunian objects into one group, Brown realized that the similarity of the Keplerian elements is preserved in all of them, and the influence of the outer stars, in this case, can already be excluded, only a constantly present planet can serve as an explanation for all these strange orbits. All of them look in approximately the same direction, all are grouped in space. The aphelion of an unknown planet, the point of its orbit farthest from the Sun, should be located particularly on the opposite side from the Sun to the cluster of aphelions of objects scattered by it. Brown and Badigan, who turned out to be office neighbors at California Institute of Technology, began to discuss all these results and began to build a model of the interaction of many test objects with the hypothetical ninth planet. Now, how was the new card obtained? Scientists have studied data on all currently known Kuiper Belt objects whose orbits are in the range of an unknown planet. Many of these objects have highly elongated orbits, which, according to Brown and Badigan, are affected by a hypothetical distant and massive planet. It took several steps to extract information about the orbit of the ninth planet. The first step was to take it into account the effects of Neptune's gravity on objects in the Kuiper Belt, and then to determine the most important areas and objects for calculations. I had to create the most plausible model using a combination of numerical modeling and observations of each object in the Kuiper Belt. This made it possible to obtain parameters indicating the most likely location of the ninth planet. From their calculations, carried out based on the results of observations of objects in the Kuiper Belt, scientists obtained approximate data on the still hiding planet 9, the ninth planet, or planet X Nibiru. The mass of this planet, in their opinion, should be approximately 6.2 masses of our Earth. The dimensions of the orbit, perihelion, the closest point of the planet's orbit to the Sun, 300 AU. The semi-major axis, the average distance from the Sun, 380 AU. The inclination of the orbit of the ninth planet, the deviation from the plane of the solar system, is about 16 degrees. If the inclination of the Earth's orbit is taken to be 0, then the corresponding parameter for Pluto's orbit will be 17 degrees. The brightness of the ninth planet depends on where it is in the orbit at the moment and on the properties of its surface. The closer a planet is to the Sun, the brighter it is, and vice versa. The average brightness of the ninth planet, according to the authors, is 22 magnitudes. For Pluto, this parameter is about 15. This former planet can only be seen with a telescope with an aperture of at least 25 centimeters or 10 inches. When asked by ex-users why we can't see the ninth planet, Brown replied, "It's easy to see but hard to find. It's like showing you a grain of sand. No problem to see it. Now throw it on the beach and try to find it again. Every star in the sky is like a grain of sand behind which the ninth planet can hide." The planet can be found, for example, by the Japanese 8-meter Subaru telescope, which has both sufficient aperture to detect an extremely faint object and a wide field of view, 75 times higher than the corresponding value for 10-meter Keck telescopes. Currently, Brown and Badigan continue to coordinate the search for the new planet with a Japanese telescope. This is on SoulAsk. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.